Hi friends, welcome to the Unit 5 Day 3 video. We're going to be picking up on perimeters of similar polygons. This is the last part on this particular video. What we're focusing here is that if the polygons are similar, then the ratio of their perimeters is also going to be similar. It's going to be the same. So if we add up all the sum of the parts, it's also going to give us the same perimeter. I apologize, man. Daylight savings time is getting to me. Which we found also up here in this example. So that's all from this one. It's actually just giving us that information. So this gives us a lot of useful information when we go into different types of polygons. We're going to be talking about triangles. So we can extend this concept to a triangle. And so that the parts of the triangle, this could include side lengths, because the side lengths on the triangle can be similar. We could have altitudes being similar. We could have medians. We could have mid-segments, and there really is a lot more. There's more than we've even covered in this class so far. So I'm just going to leave it with those ellipses. That's what those three dots, those three periods, consecutive periods are called ellipses. It means it goes on. It means there's a lot more that we could put there, but we just don't have time. We got to get through these notes. So corresponding lengths in the similar sides. If two polygons are similar, then the ratio of any of the corresponding lengths in the polygon is equal to the scale factor. So what we're saying is that the scale factor is, as soon as we know the scale factor, we can use that to find the value of anything in the triangle. So let's do this example here. So we're going to be using the scale factor, knowing that this triangle, knowing that these two are similar. So we have to start with that. So if these two are similar, then I can use this information of knowing that the length of t to r, so that's the whole length here, over the length of x to z, is going to be similar, is going to give us a value. That's going to give us the scale factor. So t to r, so that's 12. 6 plus 6 is 12. 8 plus 8 is 16. So these reduce down. 4 goes into both. 3, and then 4 times. So the scale factor of this triangle is 3 to 4. So knowing that the scale factor is 3 to 4, now I can find the length of the variable. So specifically, I think there's a variable here that's missing. Yes. So on here, we'll put the variable right here. We want to know the length of this. So for here, we want to find the length of this variable x. So what we're going to do is we're going to start with the scale factor. So 3 to 4 is equal to, so 3 goes on this side. So that means my x variable has to go in the numerator, similar to where the 3 was, over 20. Now we cross multiply just like we've been doing all this unit. 20 times 3 is 60. 4 times x is 4x. Divide by 4 on both sides, and you get x equals 15. So we have that variable for this one. And now let's preload the variable for the next one. So variable for this next one is, looking at my notes here, is that right here. So that x. Okay. So this one, it's a little bit more involved because it actually doesn't give us everything that we need out front like this one did. But it does give us these congruency marks. So I know that the length of this other side here is 48. I know the length of this here is 40. This 35 goes with this part right here. So it's going to this part right here. So then I know, let's see, if I'm going to find the scale factor, so that's going to give me, let's see, j to l over e to g. And j to l is 48 plus 48, so that's 96. Over 40 and 40, so that's 80. So 96 over 80, that's going to reduce down to 6/5. So my scale factor is 6 to 5, which means if I set up my proportion, so let's see, I'm going to have 6 to 5, and then it looks like my x variable is here with this first one. So I'm going to go here, and then 35 in the denominator for the second. Cross multiply, just like we've been doing. 35 times 6 is 210. Equals 5x. Divide by 5 on both sides, and you get x equals 42. That's the answer to that one. Last example, we're talking about a swimming pool. So the community park has a rectangular swimming pool enclosed by a rectangular fence for sunbathing. The shape of the pool is similar to the shape of the fence. So this told us that it is similar. The pool is 30 feet wide, the fence is 50 feet wide, and 100 feet long. So we have to be really careful understanding all this. The best thing that you can do is actually draw a picture. So generally in a community pool, they'll have a pool in the middle, and then there will be a grassy area outside with a fence. So this is probably how it's set up. So here's my grass. There we go. All right. And so let's label what we know. The fence is 50 feet wide and 100 feet long. So we're going to go 50 feet and 100 feet. And then I know the pool length is 30 feet wide. Again, making sure that I get it matched up correctly. It does matter where I put that 30 feet. If I put that 30 feet in the wrong spot, the problem won't work out. It wants to know what the scale factor is of the pool to the fence. So right now, I know that this side is 50 and this side is 30. Be careful. Pool to the fence. We need to put the pool side first. So pool and then fence. Divide both of those by 10 and you get 3 to 5. 3 to 5. So be really careful on that. It wants to know what the length of the pool is. So I'm just going to put that as the variable x. So to figure this out, what we're going to do is we're going to use the scale factor and we can multiply. So we know that 3/5 is equal to, remember 3 is the pool. We want to know the length of the pool, so that's going to be my x over 100. Cross multiply, I get 300 equals 5x. Divide by 5, and I get x equals 60. So the length of the pool is 60 feet. The pool length is 60 feet. So it says find the area strictly reserved for sunbathing. We actually want to find the perimeter for each. So go ahead and change that. If you want to find the area in addition to it, you're more than welcome to. So again, finding the perimeter, I know the lengths of these other sides are going to match up because it's a rectangle. So I know that this is 100 feet. I know that this is 50 feet. I know that this is, let's see, we found earlier 60, 60, and 30. So if I wanted to find the perimeter, 50 and 50, so let's see, let's do the fence. That's going to be 50 plus 50 plus 100 plus 100 equals 300 feet. And then the pool is going to be 30 plus 30 plus 60 plus 60, so that's 60, so 180 feet. So that's my parts for each. And that is the end of the notes for this particular section. I hope you have a wonderful day. Bye, friends.